Good evening, class. How has everyone been doing?
Good, Jerry. How you doing?
How you doing? I'm good. How about you?
Not too bad.
Glad to hear that. How about other students? Doing well?
Hi, Jerry. Doing pretty good.
Hi, Richie.
Yeah, doing pretty good, Jerry.
Hi,
Thank you for
Lena.
asking.
Yeah, can't believe that we are almost at the last 2 or 3 weeks of the quarter. So how have you found the class content to be in the past few weeks? Did it become clearer and more straightforward to you? Or did you find it more challenging compared to the beginning?
Oh, it definitely got harder.
Oh, I see. Well, then let's see how I can be helped. So in the past week, we have learned more about probability and also how to construct a confidence interval. This is closely related to what we will be learning this week regarding hypothesis testing. So has anyone started working on homework 8? There are 3 questions, and have you run into any doubts so far?
I tried it. I just don't know if I got the right answer.
I see.
We have the worksheet, but the workbook to help. But if you don't know how to navigate it, like you said it 2 weeks ago, it really does nothing to you, right? So, but I'm hoping I got it right.
All right. Would you mind elaborating some of the questions and procedures you are not sure?
I would. I really would. I just,
Okay.
I got my 6-month-old on my shoulder and he's about to scream at any point.
Oh, okay. All right.
I'm like
right.
trying to multitask
Then,
right now, but I
no
would like
problem.
to.
Just then feel free to join our discussion if it rings any bell into regards what you did. Okay, how about we start from the beginning questions? I'd like to see how some of you addressed these questions. The first one regards normal distribution, and we are given the mean and the standard deviation about the population income. Then we need to calculate the probability of a random sample. To have a mean value at a certain point. So let's begin with the first one. Can anyone volunteer to describe what you did regarding this question, part A of problem 1 in assignment 8?
I can take a crack at it here, Jerry.
Okay.
So for the first
Trial.
part here, I took so standard deviation for the sample size of 50, and I used a formula of 21,000, which is the standard deviation divided by the square root of 50.
All right.
To come up with I think what's the terminology here? A probability.
Okay.
So I took that once I did that 21,000 divided by the square root of 50. I input that information into the spreadsheet with median, the standard deviation, and this value for X, I believe, and then came up with a probability amount.
Okay. So there are 3 rows somewhat related to the probability. Which one did you choose?
Let's see here. I've got to open it back up. It takes a while for Excel to load.
No problem. It'll be just a few seconds, I believe.
Does it sound like we're on the right track though with that, with coming up with that that amount?
Yeah.
Okay.
We're on the right track.
Were you asking
There's a
which
small
spreadsheet?
correction I can make.
Were you asking which spreadsheet? Is that what your question is?
Yeah, I think so. So I use the normal distribution
Yeah.
on the probability distribution tab on the statistics workbook. And so I put in 58,000 for the mean. I put the standard deviation in for the amount that I described, how we got the 21,000 divided by the square root of 50.
Mhm.
And then X was 60,000, which is what we were trying to solve for. And that, let's see.
Okay, sounds good.
Yeah, and then that generated a probability in the 1 minus FX line.
Oh, I see. Well, great choice. So let's take a look. As John described, however, there's a terminology alert I need to make. When we divide the population standard deviation by the square root of the sample size, which is 50 here, what we get is a standard error. That'll be the standard deviation of the sample mean. So notice the difference. A standard deviation is about a random variable, like the 50 income values we derive. However, the standard error is about the mean value. So here, the mean value of the population is given at 58,000, but in a sample, we have 60,000. So the standard error is about the mean value, 60,000 here. The approach John took to get the probability is correct. What we did is basically we transform the sample and the population information towards a z-score. We have derived the z-score before, and here we use the z-score property and calculate a probability out of a z-score. So as we have noted, there are three different quantities about the normal distribution sheet we can use. What we need to put into is the mean, standard deviation, and X, right? Here, the standard deviation is the standard deviation of the sample mean, which will be called the standard error. So as long as we input the correct numerals here, we should get the correct answer. And for example, here we have 60,000, right? The population mean here would be 58,000. And standard deviation, it'll be 21,000. Let me make sure I have the, oh, I guess I actually input an extra zero there, but not too much a problem. Let me finish this one. We simply calculate the standard error as the sample population standard deviation divided by square root of sample size, right? So I get this part right. However, this is 10 times too much. So that'll be the three things we got from the established Excel sheet. And the first one means probability density. It'll be the slope or derivative we get on the cumulative probability function. And this one, the capitalized fx, as it says, is the probability regarding the sample mean, the population mean, smaller than 60,000, right? Yeah, and the next one, of course, would be the population mean greater than 60,000. So here, what we were asked is about how much is the chance we have the population mean, the average household income that exceed 60,000. So this would be the probability we should take from this sheet. I think following this method, you will definitely get a correct answer for part B as well. Any questions? Oh, there are quite a few comments.
And then for question C, it's just what we learned on the lecture. You know, the more you increase the sample size, the lower the standard deviation of your or variability of your sample.
Yeah, correct. What's being lowered is the standard error, because that's where we divide the population standard deviation by the square root of the sample size, right? And if the sample size is larger, the square root of it is also larger. That's what makes the standard error for the sample mean smaller.
Yeah, it's just, I think I'm with John, like the whole terminology is still a little challenging because you got to understand what they mean, right? As far as how you interpret them and write it your answer. So
yeah, for terminology, I go to Wikipedia a lot because there are actually many great answers.
Cool.
I was just about to bring that when we go to problem 2, because over there we need to interpret the confidence interval. And I noticed in the other full-time MBA class, not everyone was able to correctly interpret it. So I'd like to see how you can do this question. But before that, has anyone started working on problem 2? Which distribution did you choose for part A?
I chose T distribution.
Great. Does everyone agree? Did any of you choose different distribution? All right. Tilda, would you mind explaining why you chose T distribution?
I chose the T distribution because we're not dealing with the population. We're dealing with a sample.
All right.
That was the reason why I thought that would be.
Wonderful reason. Here we are given the information regarding 122 calls sampled from a call center. So they could have many more calls, but we have this much to study. All right, with this, how about we go to part B of the problem 2. I wonder how you build the 95% confidence interval for the average length.
I input the mean of 2.5 and the sample standard deviation of 0.8 and a sample size of 120, and then the 0.95 in the confidence level. And I got a critical value T of minus 1.98 and 1.98.
Mhm.
And then got the lower limit of confidence interval and the upper limit. And the lower was 2.355 something, and the
Mhm.
upper one was 2.644599.
Sounds great. Did any other students get alternative answers? All right. Wonderful, Tilda. I'm glad that you got the procedure correct. So,
Sorry, just to be clear,
okay.
the worksheet to use is a confidence intervals, and you plug in the numbers to get the values, right? Which is
Yeah.
a t-distribution.
Correct. We should
Um,
use t-distribution here.
I had a question because I was doing this research earlier, and just his videos are great, but I kind of wanted to just get a summary
Okay.
of when to use each distribution and what the differences are. And
Okay.
what you just said, Wikipedia, just like Googled it and said, okay, what is a different class? But I still wasn't clear because they all relate to whether you're using sample versus population.
Yeah,
And
you're right about that.
and one of them's 50-50. I think what was the other one called, where it's either yes or no or true or false or what have you. But again, when do you use what distribution
Okay.
in any particular question? Because if this comes up in the test, right, I would like to know, and then if you could just guide me to where that information is, because I don't want to spend more time on this, but tell me like, go read this or go to the book, or and I can definitely do that homework.
All right. Simple answer is that if we know the population standard deviation, we use a z-score and a z-distribution. If we do not know the population standard deviation, we use the t-distribution.
Mhm.
And both of these help us to derive or infer about the population mean. So if we are studying about the mean value, yes, we choose z or t distribution.
Okay, and where does normal distribution come in play? When you have a standard deviation?
When we have the population standard deviation, notice the distinction. For example, in the first one, because the income is derived from every possible individual in the United States, theoretically, right? So that's why we refer to it as the population standard deviation. However, in the second question, problem 2, the standard deviation we got is about the random sample of 122 calls. So that's why we know it is the sample standard deviation. So we do not know the population standard deviation. That's why we need to use the t distribution instead of z or normal distribution.
Got it. Thank you.
On his Excel worksheet, under the probability distribution worksheet, so when you say you're using the z distribution, because in that one we use the, or not that one, but the one before we use the normal distribution. Is that the t, because it was a t table that we use, right? Or t, let me look. T distribution for problem 2.
Yes, for problem 2, we use t distribution. However, I'm guessing you were looking at the probability distribution tab in the statistics Excel file.
Yes.
It's useful to calculate the critical value, but it's for problem 2, we use the confidence interval tab.
Right. So for that number 2, we were supposed to use the confidence interval for population mean with sigma unknown, right?
Yes, correct.
Okay.
Yeah, sigma here, where we use Greek letters to refer to population parameters. Population parameters include the population mean, population standard deviation, and other related information regarding the population. So here, sigma stands for the population standard deviation.
Okay, so when we have samples, we use the t-distribution. When we have population, we can use the confidence interval with the population or sigma.
Yeah, notice that what we know about the population must be about the population standard deviation that will allow us to use normal distribution.
So normal distribution is for population values. I mean, like, like sigma and I'm getting
Yes,
them.
as I said, the sigma stands for the population standard deviation. If we know that, and we are studying about the population mean, then we use normal distribution.
Let me ask you a question, okay?
Sure, go ahead.
Suppose you have a random sample involving population of people, would you still use the normal distribution?
Well, I guess we have to reframe our question a little bit. When we have a sample, then we do not have the population, right? So we don't know the population mean or standard deviation in your case if we only sample a few people. Then to study or to infer the population mean, then we will need to use the t-distribution.
Jerry, can you go over when she was talking about if you have, you need like a n of at least 30 to assume that you can use the, was it the normal distribution? And, but then when you're doing confidence interval, like he was saying, you need at least five sample or 5 numbers in order to use the confidence interval.
Mm-hmm.
I don't remember exactly the terms he used, but one was like you needed at least 30 in your sample, and the other one you need like 5.
Mm-hmm.
What was the difference between those?
Okay, so when we use the rule of thumb of 30, that's where we apply the central limit theorem regarding the population mean. So if we construct confidence interval either based on a normal distribution or a t-distribution, we need enough sample size to make it useful. So when the sample size is 30, the distinction between a t-distribution and a normal distribution is almost indistinguishable. So if we plot their probability density curve, they will overlay. So there won't be much difference. And if we do not have this much, then the difference between a normal and the t-distribution will be somewhat easier to detect. So that's safer to use the t-distribution rather than the normal distribution. This applies when we want to infer the population mean for a distribution that's not normal. So if we have a score, for example, the let's see what score would be easier to use. Yeah, I think in psychology there are many personal characteristic traits, and those scores are usually confined within a certain range, for example, between 300 and 750. And those scores for small size of sample, if we plot their frequency or histogram, it doesn't look like a bell curve. So if we still want to infer about the mean value of their scores, then it'll be dangerous to use either T or normal distribution if the sample size is too small. So we do need enough sample size. And at this moment, I think most databases we work with are really large enough, so we don't really need to worry about the sample size in terms of this. When you, well, on the other hand, when you describe the 5, I think you were talking about the proportions, right? We want the smallest cell to have at least 5 members in it.
Oh, that's right, proportion.
Yeah, this is because the approximation we use. When we study the population proportions, we used the normal distribution, right? You notice that we use the z-score. Here, there's an underlying assumption that we approximate the distribution about the proportions to a normal distribution. And this approximation only works well when there's enough sample size in both categories. And if it's violated, there are more intricate procedures that we can rely on that do not need that either of the group to have 5 or more members in it. So it's still workable if we have smaller sample size.
So that's 5 on each side of the proportion, 5, at least 5% or 5?
Not 5%, but 5 subjects in a category.
Okay, thank you.
Jerry, I may want to ask you more about that. Before you leave, that same question, because I wasn't really following very well what you're saying. I can understand the rule of thumb of 30 being, it has to be at least a sample of 30 in order to calculate the population mean. That is like the minimum, and that is based on that to get that, it's from that sample. Anything less than that, you can't. You wouldn't be able to calculate the population mean and confidence interval, right? But then the 5, I didn't understand what. Is there anything more that I should know about that rule of thumb, the 30, and also what the 5 really meant when Karen asked the question? I think it was Karen who asked that question.
Oh, okay. All right, no problem. My advice is that first, do not get panic or get too worried about these rules of thumb. As I said, first, modern data that we collect usually fit this criteria. And second, even if it doesn't fit, so for example, we have 25 customers interviewed or surveyed, we could still infer about the population mean, but it's just not as strong or reliable a statement as if we had more subjects interviewed or collected through questioning. So don't get too worried. Regarding the 5, as I described earlier, it's about, I think it'd be useful if we go to problem 3, then it'd be very immediately apparent. So in problem 3, we survey 61, right? Respondents regarding whether they support the president or not. And of course, there are only 2 choices. Either the interviewee the voters supported or they do not. So the rule of thumb here to apply this normal approximation to the distribution of the population proportion applies where each category, so either the number of the respondents who supported and the number of the respondents who did not support should exceed 5. So if we had only like one respondent that either supported or not supported, and all the rest were like in the other category, then it'll be dangerous to use this approximation.
You always need at least 10 response then.
Well, yeah, that's a good way to think about it.
Sorry?
Because
Is it 5 or 10?
It's 5 in either category. So because there are at least 2 categories, right? So
yes.
that means together we should expect 10 to get this right. Yeah. But as I said, if you just happen to have a very small sample, there are special procedures that we can follow to still make it useful. But as I said, it'll be not as good as if we had a larger sample size. Well, good. Let's see. I would like one of you to volunteer to try to interpret the confidence interval we built in problem 2, part B. Would any one of you like to try and share with us how you interpreted a confidence interval?
Part B.
Yeah.
I can share.
Great, go ahead, Karen.
So this is 2B, right?
Mm-hmm.
So again, I think, did we talk about earlier? I thought we did.
Well, we talk about the procedure to calculate the confidence interval.
Oh, okay. So for B,
yeah.
I said after plugging it into the confidence interval for population mean with the sigma unknown, you get a lower limit of confidence interval of 2.35 minutes.
Mm-hmm.
And an upper confidence level of 2.64 minutes.
Mm-hmm.
And so this means that I have a 95% confidence that the average length of all phone calls is between 2.35 to 2.64 minutes.
Wonderful interpretation. And are there alternative answers to this question?
Are we looking at, which question are we looking at?
It's part B of problem 2.
Oh, okay.
We interpret a confidence interval. Are there any alternative answers?
I had a question. Would that mean that this confidence interval's only regarding the sample that we're talking about, not necessarily the population, because we don't have population?
Well, that's a great question. We will address it very soon. However, I'm really curious whether all of you had exactly the same answer as Karen had in terms of the confidence interval interpretation, or are there any different answers?
I had the same as Karen.
Okay.
With the margin of error is 0.145.
All right.
Do we need to calculate the margin of error in this particular question?
No, not necessarily.
And did we have to interpret it to do the interpretation, the meaning of what it means, or just provide the confidence interval?
Well, we do have to include the interpretation of it. That's part of the question. So would you like to share yours?
Oh boy, no, I didn't include it, but I could.
Okay. And what are your thoughts at this moment?
What I would say is that with a confidence level of 95%,
mm-hmm.
the confidence interval is between 2.36 it's two, I mean, you get 2.36 calls, and with an upper limit of 2.64. So that is the range in between the number of calls.
Okay.
That your mean should be within that range. Or
I don't think it's a number of calls. I think it's the duration of the call.
the duration of the calls. Okay, yeah.
Length of phone calls, yeah.
Yeah, length of phone calls. Okay.
Okay, well, sounds good. I'm glad that so far the common errors I got from the other group of students were not showing at this moment. However, I would encourage you to look at the what it means by this 50% confidence. Let's see. I found the confidence interval interpretation page on Wikipedia really useful because it includes this chart. So here, this is the population on the top of this chart. It has a population mean of mu. And we sampled this population 20 times. And each time, of course, we have a different sample mean and a different sample standard deviation, and also potentially different sample size. And each of them, each sample, we can derive a confidence interval, 90%, 95% confidence interval, right? But here in this example, they derive 50% confidence intervals. So the concept is similar. What this 50% represents is that if we constructed 20 confidence intervals out of 20 samples, 50% of them or 10 of these confidence intervals would include the population mean here. So as we noted, the blue ones include the blue confidence intervals encompass this population mean, and the red ones do not. So that's what a percentage in the confidence interval means. It's the long run property of a confidence interval. So however, we also noted that if we have only just one sample, right, here in our problem, we have 122 calls. We did not sample the phone calls many more times. So we have only one sample. And in this occasion, the population mean or the average phone call length will be either in our interval or not. So there's a distinction between one sample outcome and the average outcome of many different samples. And if you're interested, you can go to the interpretation part. There are a few misunderstandings that you can avoid. All right.
This might be a dumb question, but why would we use sigma known in what situation when we know sigma, which is your that standard deviation?
In my personal experience, very few cases that we actually know the population standard deviation.
Okay.
There are examples. For example, the IQ score. In many psychological studies, they try to relate IQ score with everything else that the psychologist could possibly think about. And in this occasion, the IQ score is designed that it has a standard deviation of 15 and a mean value of 100 over all human beings. And they use this property to derive certain probabilities. And if we study about the public health, generally we know the standard deviation of for example, the BMI, the body mass index, and index for weight or general health, or also the standard deviation is also known for the body height of subpopulations, like by race and by gender. So these are used for specific studies. And in business, I so far have not seen many uses where the population standard deviation is known. So in most cases, we would depend on t-distribution to infer about the mean values.
Understood. Thank you.
Well, great question. And glad that many of you have really paid attention to small details. This is good. So any further questions regarding problem 2? If not, we can move on to the population proportions.
Yeah, hey Jerry, for moving on to problem 3. So I tried problem 3. I ended up using the confidence interval for population proportion. In my sample proportion, I took 61 divided by 284, which were the 61 respondents out of the 284 randomly selected eligible voters, which gave me a proportion of 0.21479. And then I plugged in the sample size of 284. And then for this first question being 95% confidence level, I then got that with a 95% confidence interval, the proportion of all eligible voters who would vote for former President Trump would be between 16.7% and 26.3%. Did I do that right?
Yeah, sounds good.
And then I did the same thing, but then for 99% confidence interval for part B.
Oh, beautiful and smooth. Did other students have the same or different answers?
So, I mean, so the interpretation of that, so the interpretation of that would be 16.7% people voting for Trump. Would that be the interpretation? I got the answers for the confidence levels, but the interpretation.
Oh, okay.
Irene, could you repeat what you said, please?
Yeah, no problem. So I think Tilda, you got probably the same numbers, right, for the lower and the upper limits. So the way that I interpret that is based on this poll that they did, where 61 out of the 284 said that they would vote for him. If you sort of, I don't know what the right terminology is, but if you sort of look at then the, if that is representative of the population, then based on that, then we would then guess that at the population level, it'd be between 16.7 and 26.3% would be voting for Trump at the population for eligible voters, based on the poll that that was done, which was 61 divided by 61 out of the 284 said that they would vote for Trump.
Yeah, sounds good.
So, so you're saying based on this poll, and out of the 61 people, then
yes, yeah. So the yeah, so the 61 out of 284, the sample proportion is about 21.5%, right? If you just do the math, that's just based on the poll. So using that information and using the confidence interval population proportion, it then tells us that from a population perspective, we would then expect that the range of people who would actually vote for him is between 16.7% and 26.3%. So at least 16.7, but at most 26.3, just based on the poll. But Jerry, let me know if I'm interpreting that right.
Sounds good. What statisticians would use this confidence interval informally is the way you did, because the confidence interval contains informally known as the plausible range of the population proportion.
Hilda, I think an easier way to interpret it, if you just look at the question, like exactly what it asks, that's exactly what your answer gives you. So it says find a 95% confidence interval for the proportion of all eligible voters who would vote for former President Trump. So your answer would be there's a 95% confidence interval between 16.7% to 26.3% for the proportion of all the eligible voters who would vote for former President Trump.
Well,
Okay.
smart way.
That's great. Thank you. Thank you, Irene, as well. And thank you. That is a quicker one. Thank you.
No problem.
Welcome.
So any more questions regarding problem 3?
I just had a quick question.
Mhm.
I was working this problem before session, but for some reason my workbook shows an error when I'm trying to type in the sample proportion and the size.
I see. Yeah.
That's my issue, but I didn't touch the formulas. Obviously, it's only the gray area that you fill in, but is that because I'm doing something wrong?
Well, that's because you can make some corrections, so it works. I'm thinking that the possible reason is that for the proportions, you supplied the number of voters voting in favor, right? However, it needs a proportion, which means it must be a fraction in between 0 and 1.
Right, which was 0.215.
Yeah, so you need to make some calculation and supply it to the cell value.
Right. Gotcha. Okay, let me try it again. Thank you.
Yeah. Have any of you used confidence intervals before?
I read about it in the science journals, but
Okay.
I never actually had to use it like at work.
No problem. I think in the future you might find it more frequent and very useful.
And can I use this for the lotto tickets?
What do you mean? Lottery tickets?
Yeah, a confidence interval in my numbers.
You could, but it'll be not very meaningful. The reason is that all numbers would be of equal chance. So showing the confidence interval also shows you nothing about which one is superior than another. So, yeah.
Unless you're doing stocks.
Well, in stocks, yeah, it could be useful. But however, as I showed you before, if we build one confidence interval out of one sample, then like it shows, it either contains the population mean or not. So yeah, ideally, if we could sample many times, then it would be better. However, in business, we could also use confidence intervals in many occasions. For example, I was working on a marketing project regarding the marketing effectiveness of a few channels. There are 6 channels that are studied here. Either we can market by email or social media, or phone app download, or SEO, that's the search engine optimization, or SEM, search engine marketing. And there are also physical event attendance that we can rely on. And from the proportions of the customers that converted after their interaction or not, we can build confidence intervals regarding this proportion of conversion. That's a quite typical performance indicator in marketing. How many customers after this marketing interaction would convert to paying customers. That directly tells us the effectiveness of marketing, because we want the audience of marketing channels to become paying customers. And here, using confidence intervals, we can make the comparison between the conversion percentage more appealing and of more confidence. Lots of times when we compare this percentage, we find they are somewhat close. For example, the conversion percentage for email is 6.3%, and that for social marketing is 6.5%. They're close, but we also want to know whether they actually differ between each other. Then that's where we can take advantage of the confidence interval. There are some confidence intervals, not exactly the same procedure as we work in our homework problems, that we can adjust these confidence intervals to make the comparison, so that if the two confidence intervals overlap, that means the upper limit of one confidence interval is larger, right? Is higher than the lower limit of another. Then we know that they are not significantly different. So the true proportions of these two marketing channels about the conversion percentage would be similar. So we can use confidence intervals to compare marketing performance. And we can also derive the confidence intervals for effects. So for example, these effects would tell us if we, so the upper left one, for example, if we build confidence intervals, then that means if we send one more email, how many customers are expected to convert? And here it's 0.21, so like 20%. If we send one more email, then 1 out of 5 emails would link us to converted customers. So confidence intervals can be built in different occasions, not just proportions, but also on this effects. And we can also calculate probability regarding the, confidence intervals regarding probabilities. So it's somewhat similar to the proportions. And if we find some marketing campaigns to have a higher conversion probability, then it's more convincing and promising. And then we want to make sure whether this marketing channel is actually very different or much higher than others, right? So that's where the confidence intervals will help us to judge whether the difference is just by chance or there's actually some systematic difference that we can detect. Yeah, so that was just some additional occasions that we can apply confidence intervals. And in this week, we will find what we just learned is also closely connected to hypothesis testing. Yep. Thank you for joining me, and I hope you can enjoy a wonderful week.
Thanks, Jerry.
Thanks so much, Jerry. Have a good night.
You too.
You.